Hello, this is Dr. Bitla coming in front of you in continuation to the previous chapter, that is CNC part programming. In the last session, we have seen the G codes, M codes, programming formats. We have seen, then we are also discussed the cycles, what is CAD cycle and different types of CAD cycles. We have seen like peg drilling cycle, thread cutting cycle. Then we have seen the uh, turning cycle also we are discussed along with the example. But now today's exam session we will go through the examples, what exactly the program looks like, and we will discuss the sample examples, including taper turning, step turning, facing, and to move how to control the tool on the work plane. The basic idea of this session is to discuss, to write the sample programs, very simple programs, which includes the operations, lathe operations like facing, turning, step turning, taper turning, and like uh, which including all these operations. So individually we will see. Then the first example, okay, before going to that, we will see the what are the steps involved in CNC part programming. We will see what exactly the steps involved in part programming. Basically, the part programming in steps is, the first step is we need to study the part drawing carefully. Based on that, we will come to know what are the machines used and what are the steps involved and what are the cutting parameters required. We come to know when we read the part geometry completely or carefully. Then this drawing can be a production drawing, or it can be a design drawing, any of the drawing generated from any of the software, 3D modeling software, which includes all the machining information. The first and foremost step in writing the CNC part program is that, once again, I emphasize you that we need to read the component carefully. We need the component drawing very carefully. So then we proceed further to see the method of work, like work clamping devices select. So based on the, if we are performing, if the geometry is rotational component, and we need to go to the machine, lathe machine. Suppose if we have a prismatic component, in that case we need to choose the milling or any other machine. So by looking into the geometry of the machine, then we have to select the number of parameters also, speed, feed, and depth of cut, and what are the clamping devices or the holding devices to hold the workpiece firmly, and also sometimes to hold the tools firmly during the work. So this is all we require. Then to write a program, if many solutions are possible, so try simplest solution, but better to propose in this way. Okay, so if there are number of solutions, we need to find out the optimizer solution for that. So then prepare a tool chart for the diagram. So we need to prepare the tool, what are the tools required, then the machine tools required, and then the clamping devices required, and enter the compensation value if necessary. So after writing the program, after deciding, after looking all these geometry, cutting parameters, we write a part program, right? Then if you have any optimizer solution, we should choose that optimizer solution. Then prepare the tool chart program and measure the tool geometry, length, radius, and all those. If necessary, we need to provide the compensation. In the last session, we discussed what is compensation. So in this case, we need to select, if necessary we need to provide the compensation also. Then clamp the workpiece in a certain position, then enter the compensation value if necessary. Then test the program, by using a dummy piece or without using a tool. Just we have to run to check the tool path, whether the tool path is properly, whether the tool on the work plane is moving properly or not. So once we confirm the tool path, once we satisfy with the program, with the dummy part or some other dummy movements, so then we can proceed further to start the mission. This is what the procedure of the are the steps involved in any of the part basic steps involved in writing CNC part program. Then let us see, before writing the part program, before entering into the sample example programs, let us recall what we have discussed G codes and what are the different types of G codes and what is the function of the G code, function or description of the G codes. Let us recall all. Then G00 is one G code, and its functionality is to position the tool rapidly. So whenever we want to move the tool rapid mode, in a rapid mode, we use G00. So that means in all the ideal movements of the tool on the work plane, we are going to use G00 command. Then G01 and G02 are the tool movements. G01 is for the straight line. Whenever we want to move the tool in a straight line path, like milling operation, right, drive facing operation. In that case, we are going to use G01. Then even turning operation. So G01, while performing turning operation, we're reducing the diameter from so and so length to so and so diameter to so and so diameter for a length. So in that case, also the tool needs to move linearly. uh, G01 is used. Then if you want to move the tool in a curved path to produce the contours, in that case, so we are going to use G02. Suppose if we want to produce the complex geometry profiles, in that case, the tool needs to interpolate circularly. So we need to move the tool in a curved path. In that case, we are going to use G02 command. Then uh, clockwise or anti-clockwise. So G02 is circular. Whenever we want to move the tool in a circular path, we use G02. Whenever we want to move the tool in a counterclockwise direction along the circular path, that is G03. Then whenever we are working in the XY plane, we can shift the work, uh, cutter into XY plane, we can use G05. To shift XZ plane, we are going to use G17. To shift the tool in YZ plane, we are going to use G18. All these are the uh, commands, are the instructions, are the codes we need to use while writing the program. Then G28 is thread cutting. Whenever we are performing thread cutting operation, we have to use G28. All these, and tool compensation, tool radius compensation, G33. So all you are aware, all this. Then let me move some more commands here. Then we have G71. Whenever we want to specify all the values like the feed and depth of cut in metric units or the millimeters, we need to specify, instruct the mission using G71 code. Then cycles we have seen in our last session. Whenever we have the repetitive cycles, the work is in repetitive nature. In that case, we are going to use the cycles, which may be a turning cycle, which may be a turning cycle, or it may be a threading cycle, or it may be a drilling cycle. In that case, we have different cycles. Those are called the CAD cycle, where we have the repetitive work. In that case, we use G76. Then 80 is the code used to cancel the CAD cycles. So unless we cancel the CAD cycle or the cycle repetitive cycle, it goes on continue. So somewhere we need to close that cycle. So to close that, to cancel that cycle, we are going to use G80. And similarly, each cycle is having a definite G code. Each cycle will be performed by using a definite G code. If it is a drilling cycle, we are going to use G81. With the dwell, sudden period, the tool is going to stay certain period. In drilling, G82. Then peg drilling, deep drilling cycle, that we use G83. Then 90 is absolute programming. The values or the coordinate values of the tool is provided with respect to one origin, that is called the absolute programming. So this is all we can use. And 91 is incremental programming. Then if you want to specify the feed rate in mm per minute, even per per minute also we can specify. This will, I mean, normally this per minute will be in the case of milling or in other operation, like especially uh, where we have the rotation of the workpiece, where we have the rotation of the tool. In that case, we use feed rate. We express the feed rate in per revolution. Whereas if the tool is moving linearly, in that case, tool or the workpiece is moving linear. I mean, rotating linear. I mean, rotating. So in that case, we use per minute. Then constant surface speed or cutting speed. Suppose while performing the operation, if we want to maintain same speed throughout the operation, we use this command. So these G codes are the commands are specific to the uh, tool motion commands, or which are respected to which are specifically used to control the tool movements on the work plane. And these G codes are not responsible for the controlling of the machine. These are only responsible for the movements of the tool on the work plane. So please remember this. Then M codes are responsible for the controlling the machine. These are specifically intended for controlling the machine. Example, you see all the operations related to the machine, like coolant on, coolant off, then clamping, unclamping, program stop, spindle rotation of the spindle in clockwise, rotation of the spindle in anti-clockwise direction. All these will be happened using the M codes or the miscellaneous codes. I repeat this, G codes are used to control the tool movements on the work plane, whereas the M codes are used to control the machine. This functionality is entirely different. So let us see further. Let me move further to see to write a simple CNC program using G codes and M codes. Then other words like the tool word, T word, spindle word, then F word. Using all those, so let us try to write one simple program to move tool from one location to another location. Assume that there are 3 points. There are 3 points, as you can see here. You can see the figure here. The objective of this program is to move the tool uh, between these. I mean, the tool should placed at 3 locations, or the tool should move these 3 locations, passing these 3 locations. Might be this type of operation is used for drilling, or this type of operation gives us some picture to move how to move the tool from one location to another location. So that is the idea of this program. So this is exactly the figure. The coordinate of the first point is the x coordinate value is what is that value? The first is 50, and y coordinate is 20. But in the case of drilling operation, so we have only 2 coordinates. One is x and z. X-axis is the transverse moment of the tool, and the z-axis indicates the axis of the workpiece, axis of the rotation of the workpiece. So, please recall that if it is a drilling machine, z-axis indicates the z-axis lies in the vertical plane, which tells us the axis of the tool that lies in the vertical plane. Okay, so this consists. So let us recall the basics that were already discussed in our last sessions. So now you see here, this is the first point lies at 50, 12, and the second point lies at 30, 35, and the third point lies at 12, 55. So these coordinates needs to specify in the program to move the tool in a rapid mode. Let us see what is rapid mode and how to specify these in the program. So let us write a simple program here. And as you can see, so a program consists number of blocks. As I said in the last sessions, a program consists number of blocks. A program is responsible to complete. So one to complete one component. A component consists number of uh, operations. Okay, so one operation is responsible for one block. So one action is one block is going to, a program consists number of blocks, and each block is responsible to perform one operation. So number of operations are performed by single program to get one component. This is what the basic idea of the CNC program. So each block, as you can see, this is the first block, and this block consists the number of words. You can see N001 is a word, N word, which signifies that it is the sequence number of the block. So N001. So this number need not be in serial order. It can be increments of 10. It can be increments of 20, 30. So need not be serial number. So this gives us some flexibility to include whenever we want to modify the code. So we can embed some code in between the lines, in between the blocks. That is what the flexibility. So you can take the program, and if we want to use the same sample of code for other operations, like for other component, so we can modify, we can take this code and we can modify according to the requirement. So to embed the different blocks of code, so the sequence number need not be serial number. That gives us so very good flexibility to modify the program, existing program. So this serial number need not be sequential, need not be in order. uh, it need not be 1 2 3 4 5 6. It can be increments of 5, increments of 10. That is according to our requirement. So this gives us some flexibility to embed some code whenever we want to modify that. Okay. So let us see that. So in this sample program, of course, the sequential number is specified in order, but it is not necessary it should be in order. Now you see here N001 is a sequential number, N word, which signifies that, which tells us this is a block and it is a block serial number. Block serial number is 1. Okay. So then, as you can see, um, you have G00. That means initially the tool is somewhere else. So we do not know where is the tool. So in that case, so we are going to move the tool rapidly, a rapid positioning tool rapidly. I mean positioning the tool rapidly. So we are rapidly positioning the tool to the 0, 0 coordinates. So that means where we have the origin. Of course, in some cases, we are going to specify X00 and Z00 here. If we want, we can specify. And G00 along with X also we can specify. So let us see the annotation. Let us see this with annotation also. Now you can see. So once we have annotation, but it is not allowing to zoom. So, okay. So let me move this. So here exactly you can write, you can also specify the coordinate values where to move, uh, the where to move. Okay. So now you can see even here. So even here you can specify X00, X0, and Z0. So Z0. So this indicates, but in this case it is Y. Okay. This is a drilling operation. We are in the work plane XY plane. This Z axis is the tool. So that we are in XY plane only. Drilling takes place in the XY plane, but the axis of the drill indicates the Z axis. Okay. This is exactly the drilling tool. This is exactly the drilling tool. And this is the Z axis, and this is your work plane. This is your work plane. It might be X and it might be Y. So it looks like that. But in drilling, so this is your tool. This is your tool. So with this we are performing work. So now you can observe here, this is exactly the Z axis. So the tool axis in the case of drilling operation indicates the Z axis. Now we are in the work plane. The objective of this program is to move the tool from one location to another location are the specified coordinates. So now you can see we have the coordinates. The first coordinate is X value is 50 and Y value is 12. So to these points we need to specify. This block is going to instruct the machine to move the tool in a rapid mode to x00 and y00. That's all. So whenever you specify G00, the tool is going to move in a rapid mode followed by the coordinate values that we specified. So G00 must be specified with x00 and x0 and y0. To this location, x0 and y0, the tool is going to move in a rapid mode. Then M06 we are specifying, we are changing the tool and we are specifying the dimensions in metrics so that we are indicating G01. Whatever the values we are going to provide in the program indicates those values will be measured in terms of in the units using our in the metric units. Suppose if you specify feed mm per revolution it takes, because we are specified it as an metric unit. Then we are also specifying to change the tool where mission, we are also changing the tool. Then just you see here you have a second sequence number here. So exactly we must require, we need to move the tool in G01 mode. Now this must be specified with G01. So in G01 mode and X50 and Y12. So first coordinate the tool is moving uh, 50 and 12. Otherwise, if you are performing actual work, you are going to specify G0. Suppose if you are not doing any work, so we are going to specify in this case also G00. So the objective of this program is to move the tool. We're not performing anything, so that the tool is moving in the rapid mode. So the first it was specified, G00 will continue here. So then here also, after moving tool to the 1512, 5012, so then we move tool to point number 2, 3035. Okay, so 3035 we have to move, 3035 were specified. So the tool moves to the second point, so that is also in G00 mode and rapid mode. So then the third point, of course it is a third point. So now you see here, this also moves 12, x coordinate 12 and the y coordinate 55. So that is also in rapid mode because we are not doing anything. So once you are specified, the machine will take that as reference and it moves in a rapid mode only. So next N05 sequence number, in the fourth step we have moved this tool to the 120 120, means exactly that is also one point required. If necessary we can move, otherwise you can skip this. So only 3 points were specified so that the points move, I mean the tool will move to the 3 points. Okay, if we want to, we can move the 2020. This is the reference point of the program or the mission, so that we are specifying the tool will move to the 120 120 and we will stop the program and we will start the program. We will stop the program and we will stop the spin. This is what the program. So let me move further to see what is happening in the next program. Let us see. Let me move further. Let me move further. Okay. So now you can see here. So let me erase this first and annotation. Then I would like to erase whatever I have here. So to continue with the next discussion clearly. So this gives me, okay, I'm closing this. Okay. So this is the first program we have discussed. The objective of the first program is to see, to move the tool to the 3 coordinates. So we have moved the tool third point, second point, and first point. Okay. So in this order we are moved. Okay, 1 2 3 or 3 2 1, but in the program we are moved the tool 3 2 1. So if you specify first coordinate first, it moves to the first coordinate, first point, then second point and third point. In the program the tool was moved from 3 to 1. The objective of the program is to move the tool from one point to another location. This was achieved, and this was happened in this program. Okay. So then the second program is to drill a hole. Okay, so for a depth of, write a CNC program to drill 3 holes. So you can see the component here. So the first location is at a distance of 50. Then the depth of hole is z-axis, that should be perpendicular to this work plane, that is 10 millimeter, that is specified here. Then you can see the second hole is at this location, that is at a distance of 50. And the third hole is at a distance of 60, 10, 50, and these two holes are at a distance of 50-50. X-axis is 50 for second and third drills that we need to produce. The distance between these two is 20. Okay, so this is exactly the geometry of the figure. So let me go through. Depth of the hole as 10 mm. Of course, it need not be 10 mm. I mean, the block thickness need not be 10 mm, but we are going to produce the hole 10 mm, up to 10 mm distance or up to 10 mm depth. That is what the requirement. So assuming z0 0, z is 0 0 on the surface of the plane. That means, so we are taking the surface of this plane as the reference plane on which the z value is 0. So if you move inside to this block 10 mm, if we move the tool 10 mm inside this block, that means we are able to produce a hole in between, I mean, at these 3 locations. And assuming some values, spindle speed and feed are 100 mm, spindle speed is 100 mm and feed rate is 200 mm per minute. Okay, so this is what the values that is specified, and you can use the values also. Okay, so N01 and G71 metric we are specified, and we are also specifying absolute and feed rate in mm per revolution. Okay, so mm per revolution we are specifying here. So this value need not consider some value mm per revolution, how much distance we need to move. So it should be 0.2. So this value should be 0.2. So can I take this value as 0.2 mm per revolution? So directly we can substitute that value here. Okay, so instead of taking this value, please correct this value as 0. Then because we are specifying feed rate in mm per revolution, so it is not per minute, so that this value is very less. So 200 mm per revolution is not acceptable. Per revolution 200 mm, it is not possible to move the tool. So we need to specify per revolution. So this is mm per revolution, mm per revolution. Okay, so this is mm per revolution. And instead of taking this 200, you take 0.2. So that we are filling here. Then M03, we are rotating the spindle. We are instructing the machine to rotate in clockwise direction at a speed of 1000. So you are also aware that the speed is specified with the word S word, then feed is F word. Feed we are specified, then speed we are specified, then EOB, end of the block, indicates the block we are ending at that location. So then the mission control moves to the next line, next block otherwise. So then the objective is to move. So this is exactly the drilling operation. So we have to move the tool to the different locations. Okay, we have to move the tool to the different locations. And I close this, then I close this here. So I have to move the tool to the different locations. Now you see here, this is first location, second location, and the third location. Okay, so first location is at a distance of 10, x coordinate is 10, and the z coordinate is also 10, because the depth of the hole that we are going to produce is also 10. So x and z. So please take this, please correct this as z value, this correct this as z value. So x value is 10 and z value is 10. That means, so the tool is moving 10 and 10. Okay, so of course this is xy, of course in the xy plane, so this is also 10, of course, otherwise 10 10. So now you keep this value as it is, now you keep this value as it is. So x value 10 and y value 10. So x value is 10 and y value is 10, and you, I mean, in the rapid mode we are moving the tool to x10 and y10. Okay, so of course we need to consider y coordinate also. So x coordinate is 10 and y coordinate is also 10. Then the z axis is the drilling operation. So now you see here, so now we are just moving in a rapid mode. This we are moved tool in a rapid mode. As you can see, we are moved tool in a rapid mode. Okay, so now you can see. Okay, let me close this once again, and I reopen this. Then you see here x is 10 and y is 10. We require x is 10, x10 and y10. So then we will, this is in rapid mode, the moment is in rapid mode. Then we move tool just near to the work plane, just 2 mm over the work plane. So this is our work plane, this is our work plane, of course about 2 millimeters. So 2 millimeters initially we are keeping the tool 2 millimeters. We are locating the tool instead of directly going to that work. So we are moved exactly the tool 10 10 and as well as 10 mm above the 10 mm over the work plane. This is our work plane. Now the tool is at a distance of x coordinate 10, y coordinate 10 and z coordinate as 2. As you can see, x10, y10 and z coordinate as 2. So now we have to uh, we have to drill a hole of 10 mm depth. Now you can see, now the mode is linear mode. Now the tool is moving in a linear mode, G01. Then the depth is up to minus 10 mm. So as you have seen that the work plane is Z00. If you go inside, it will be negative. If you move up, it is positive. So this is Z positive. Okay, Z positive value. So if you go inside this plane, it is Z negative value, Z negative. So that, so now we are moving tool to drill a hole of 10 mm inside the work plane or inside the workpiece for a length of 10 mm, for a depth of 10 mm in linear mode. That you can see in linear mode we are moving the tool. We are moved the tool here. Now you can see, so this is what the first drilling a hole at point 1. So at this location we are drilled a hole. So now similarly you go to the I mean, just we are drilled a hole. So then move the tool to 2 mm up. Again we have to come back 2 mm above the work plane. Okay, after drilling. So now at this location the tool is at minus 10. So now we have to come back to the reference plane. So 2 mm above the reference plane. We are coming to the 2 mm above the reference plane. So again in the rapid mode, because we are not doing any work here, it is coming to the initial position or the 2 mm above the work plane. We are instructed. So then uh, we have to move the tool to X as 50, but Y value is 10. Definitely the Y value is 10 only here. So with respect to the first and second locations, the Y coordinate value is 10, so that the Y coordinate value is not specified here. Only X value is specified, that is 50. So now the tool moves to the Y is equal to 10 and X is equal to 50. X is equal to 50, you can see here. Okay, so now the tool has moved to X is equal to 50, Y is equal to 10, and that is Z is equal to 2. That means above the work plane. That is, I mean, the tool is about 2 mm from the work plane. Okay, so now let us see, we have to drill a hole. We have to drill a hole of 10 mm. So that takes place here. Now that is all happening here. Now you can see G01 and Z, we are moving towards minus 10. That means the drill is drilling a hole in a straight line mode for a depth of 10 millimeters. This corresponds to the drilling operation at second point that you can see. So Z minus 10, Z minus 10 we are specified at X is equal to 50 and Y is equal to 10. That means we are drilled a hole. So now the third point also completes here. So 30, Y he is specified, okay, X value is same as X value is 50 only for the third hole. Then the Y value is 30. So this is 10 and 20, 30. Y value is 30, X value is 50, and 50 30. So okay, 50 X value 50, Y value 30. We move the tool inside the workpiece up to 10 mm. That means we are drilling third hole. So this completes. Then G00 we are coming to the Z20. That means we are moving tool to the 20 mm above the work plane here. 20 mm above the work plane. This is what uh, the completes. So the drill moves in a rapid mode 20 mm over the work surface at point 3. At point 3 only, the drill will move 20 mm above the workplace. Okay, so then we are moving to 00 mode where we have assumed one X0, Y0 here. So we have assumed X0, Y0. We will move the tool to X0, Y0 also. Okay, so then we will stop the program. So this program, the idea of this program is to drill a hole at 3 locations for a depth of 10 millimeters. So very simple program and very easy to understand. And we are also used some miscellaneous commands. Spindle we are rotating in clockwise direction at a speed of 1000 millimeters, 1000 rpm. Feed rate we are specified 0.2 mm per revolution. Okay, so then we are used stopping the program. All these are miscellaneous commands. And then we are moved tool in a rapid mode, and during the idle motions of the tool, ideal movements of the tool, we use G00. Then while cutting operation, while the tool is in cutting operation, we use G001, G01 G code to complete the work, to do actual action. This is what the simple program. Now let us see these are the simple operations of the drilling operations. Okay, moving the tool and drilling operation. Now let me move further to see uh, the facing, on the lathe work. So as of now, we have seen some drilling sample code and moving tool on the work plane. So the basic idea of these two programs is to move the tool from one location to another location. Now let us see how to perform work, how to write a program on the lathe machine to perform work or to do operations on the lathe. So there are some basic steps, and we have some assumptions as we have seen in our last class. X-axis is the transverse movement of the tool, and Z-axis is the axis of the workpiece. So this we need to keep in our mind. So in any of the drilling operation, any of the turning operation, we have only two axes involved. Two axes are going to involve. One is X-axis, that is the transverse movement of the tool, and the other one is the Z-axis. Uh, that indicates the axis of the workpiece. So X and Z axis. So now you see the first step to write the lathe operations is move the cutting tool to a point near to the job in the rapid mode. Yes, somewhere else. We have a tool somewhere else, or it may be 00, or it may be somewhere else. Moving the tool to the workpiece near to the workpiece. It may be that is called approach distance of the tool. We can assume while writing the program need not be same for if I write program, the program is different because I'm assuming approach distance as 2 mm, and if somebody assumes that approach distance is 1 mm, the coordinate values entirely changes. So this is what the program concept. So move the tool near to the workpiece. It is called the approach distance, which may be 1 mm or 2 mm or 3 mm according to the programmer's convenience. So the tool will be moved near to the workpiece in rapid mode. So then set the linear interpolation and move the required depth of cut. So set the linear interpolation, just move the tool depth of cut, then perform the operation, perform the turning operation, moving the tool in z-axis direction. Okay, so assume that we have a tool here. So we have a tool at this location. We will see while writing the program here. So then, let me erase all these here. I'm erasing all this. Then I'm also closing this to move forward to write. Now you can see moving along the z-axis is the required length of job to be cut or to be for drawing. So just giving depth of cut along x-axis and moving the tool for turning operation is annotation. Then I'm not getting the cutting. Okay, I close this. Then I have okay, I have the annotation here. Then okay, now you can see. Let me take out this. So moving the tool to the along the z-axis really gives us the actual operation. So set the rapid mode and retract height. So after completing the work, so I will tell you this program. Now we will discuss the steps with an example. So this is actually the workpiece which is held in the spindle, assume that, and this is the axis of the uh, workpiece. This indicates the z. So normally in my programs I'm going to assume origin at this location. In almost whatever I programs I'm going to discuss, so my origin lies at this location. Here the x value is 0 and z value is also 0. So I'm assuming origin. So this is your x-axis. That means the axis of the workpiece will indicate the z-axis. Now this is your x-axis. So z-axis and x-axis. So my origin is at this location. So what he is trying to say in the steps is initially the tool may be somewhere else. So move that to 0, 0 first. Move the tool to 0, 0 in a rapid mode. Then from here, then move the tool near to the workpiece. So first step is to move the tool to the 0, 0 position. The second step is moving the tool near to the workpiece by giving some approach distance along x, or this is the approach distance we need to provide. So which may be 2 mm or 1 mm or 3 mm according to the programmer's convenience. So now moving the tool approach distance along x and z axis. So now just you keep the tool at this location. So the z axis is 2 mm clearance between the work and tool. Then x axis is also 2. So now you provide the depth of cut. Okay, so now you provide the depth of cut. So assume that now I am locating the tool at this location. So I'm giving depth of cut as 3 mm or 2 mm. That means so whatever the value that we have here, so just you provide that value 2 mm depth of cut. Then moving this tool along negative z axis. This is our negative z axis. So we are moving tool in this direction. So this is our negative z axis. So if we move the tool to the negative z axis by providing the depth of cut, so which gives us the turning operation. This is the basic idea how to write a program, turning program in CNC. So this is what I followed on all the programs. I have given almost in all the programs, I have given 2 mm depth, 2 mm approach distance, and the depth of cut. Almost in all the cases, the depth of cut is not going to exceed 5 millimeters. And the sign conventional axis is that my origin is at this location, which lies at the axis of the workpiece. Then this is my positive z axis, this is my negative z axis, and this is my positive x axis. positive x-axis, and this is my negative x-axis, negative x-axis. So this is what the convention I follow to write the program. Okay, so then I erase this to clearly to discuss what I am going to explain in the coming example. Okay, so now I'm closing. Just let me move further. So uh, we have one program here. Uh, write a write a CNC program for facing operation on a component shown in figure 12A. So we have a component. We have a component in this. Basically, this is the component. So for this component, the objective is to perform facing operation. So using facing operation, we need to reduce the length of this component to 0.125 millimeters, 0.125 millimeters. The diameter of this component is 1.25 centimeters. Of course, in this case, the values are in centimeters. And the length of this component is 2.25 centimeters. So all the values are in centimeters. Now let us see the movements of the tool first. So now the tool is somewhere else. We have to move the tool linearly. So this is what the pattern that we see in the program. So moving the tool in along z-axis, then moving the tool along x-axis just near to the workpiece, then moving the tool to the center. uh, okay, so by giving depth of cut, but here we have given depth of cut for facing operation, moving the tool near to the tool by providing some approach distance and along with the depth of cut. So then moving the tool to the center will complete the facing operation. Actual cutting action takes place during the C. During the A is the linear movement of the tool along z-axis in negative z-axis. Then this is the x-axis. Then by providing the depth of cut, then you move the tool to the center. So the tool actual cutting action takes place. Then we will move the tool backwards along z-axis. Then we move back. So now you can see we are moved back. Then we are moved back. Then we came to the initial position G. So these are the movements that we perform in the program. Let me go back to discuss the program. Okay, so now you can see G00 is for some G code and G40. So let us see what is G00 and G40 is for the providing the units and providing all the values. Then we discuss, we move the tool to the X00 and also Z00. That means rapid values, rapid positioning the tool to the X00 and Z00. Okay, so the tool will move to the 00 point um, somewhere else. Of course, somewhere else in the tool may left somewhere else. So initial step is to move the tool to 00. Machine 00 or the reference point of the machine. So after moving the tool to the reference point, so then we will select the tool using the T word or T code. So then we have G54 and work coordinate system we are providing G54. Then we provide the speed. Then we rotate the spindle in clockwise direction like this. We have provided M code. Then moving the tool in a rapid mode to 2.25 centimeters. Now you see rapid to the position Z, A motion. So now we have seen the motion is A. A means moving the tool rapidly to the 2.25. Okay, so just the tool is moving, the origin is at this location. So the origin is at this location. So the tool is going to move 2.25. That means if we move the tool to 2.25, our origin is at this location. The depth of cut is already given. Okay, so once we move the tool to 2.25, so that includes the depth of cut. Okay, because the original length is 2.25. So whatever the value is extended beyond this point, so that will be I mean the machining will takes place during the facing operation. Okay, so the A movement we have done, then we see the B movement. Okay, so then we see the B movement. So the B moment is that, so 1.35, X is 1.35, then M is 0.8, rapid, so 0.1 centimeters away from the part. That means we are giving some approach distance also. Basically, this is 1.25. 1.25 will be the distance, but we are giving 1.35, some approach distance. Okay, so that includes that. So now you see, just you go back to the figure, 1.25. Okay, so then we need to provide the now the tool is at this location. Now the tool is at this location. This value is 1.25. Then we are giving 1.35. Okay. So okay. Again, once again, I share. Then I move. Then I move forward to see. Okay. Then this is what the depth of cut we are given. So 1.1 includes the uh, clearance also. So the tool may be at this location. So exactly at this location. So now go back to the program. Now go back to the program. So 1.35 will be the distance, and we are moving the tool in a rapid mode. So we're already given here. So Z is 2.25. Obvious it is Z is 2.25. Rapid to the position Z. Yes, of course, rapid to the position Z. So Z value. So now we are at this location. Z value is 2.25 and X value is 1.25. That means X is 1.25. This is 1.25. It is just above 0.1 centimeter, just above the X value. So the total diameter is 1.25. And we are adding some clearance before cutting action takes place. So I will tell you this. So now the tool is it at this location with a clearance of 0.1 0.135. Is it 0.135 or something else? Let me move further. Then the clearance value is 0.1. Okay, 0.1 and 1.35. So we are provided there. Then we have instructed rapid 0.1 away from the part and 0.2 on the diameter. Diameter wise it is 0.2. Okay, but whereas it is half, so it is 0.1 only. So then we move the tool with a feed of 0.06, with a feed of 0.004 centimeters. You can see this value is specified in the problem, 0.004 or 6. Okay, 0. So you take this value as 0. So this value is already specified in the problem, so that you take it as 0.004. Then moving the tool in rapid mode, sorry, linear mode. Linear mode, we are moving the tool to x00. That means, so now we have the workpiece, and this is your z, okay, and x is 0, 0. So this your z axis. So now we are moving tool to this location. That means x value is 0. So now the x value is 1.35. So before starting, this is at this location, tool is at this location. So 0.135 centimeters. Now we have moved tool here. We have moved tool to complete the facing operation. So now the facing operation will be completed by giving depth of cut, that is 0.125. 0.125. Okay, so then moving tool to the z is equal to 2.3. Okay, away from the tool. So we are moving the tool 0.05 centimeters away from the face. Then machine control units. Then we are moving tool to the 0, 0 locations. So this completes the facing operation. So now let me close the session for today's. We have seen the programs of simple facing operation. Then we have seen the drilling operation program. So at 3 locations, we have drilled the hole for a length of 10 mm along z-axis. Then but in this case, we need to provide 3 coordinate values: x, y, and z is the depth of cut here, depth of hole. Then the first simple program is to move the tool from one point to another point. So we are moved on the work plane. We are moved the tool on the work plane from one point to another point. So this is what we have seen in the today's class. But in the next class, we will see the summer programs to move the tool or to perform the turning operation. As of now, we have seen the drilling operation, then facing operation. We are moved, the first program is we have moved the tool to the different locations on the work plane. But in the next session, we will see the turning operation, plane turning, step turning, and the taper turning. We will see the programs in the next session. So thank you one and all. And